Welcome to the Algebra 1 Keystone Practice Exam 2019. We're looking at Module 2 here. I'm going to be going through all the questions here in Module 2, so if you want to see a question specifically, feel free to fast forward the video to that question. Let's take a look at our first question here, number 1. A graph of a relation is shown below. All right, we've got our relation there. It looks like a nice little quadrilateral. And then it says, removing which line segment from the graph would make the relation a function. Well, remember when we're dealing with relations on a graph and we're determining whether or not it's a function, we're going to use something called the vertical line test. The vertical line test is if you can draw a vertical line at any point and it hits the graph or the relation more than once, then it is not a function. And so if we look at some vertical lines here, we can see where it is hitting and which problems are being caused as we go through here. And I'm looking at various vertical lines to see where it's going through all of our different sides here of our shape. And I notice something in particular. Every single time that I have it violate with a second option here, so it hits our graph more than once, I notice the second time that it's hitting is always on this line down here. So if I were to just remove this line right here, then each of these vertical lines would only touch once, making this relation a function. And so therefore, that's the one that I want to go for. And notice it's describing it by its endpoints. So let's find those endpoints. This endpoint here is -4, -2. That'd be my one endpoint. And over here, this endpoint here is 4, -3. So that's what I'm looking there. All right, and as I see, it is not 4, -2, and -3. Nope, it's not that one. Not this one here, not this one, so it must be our option D. Let me scroll down to that, and we can see that D is indeed our answer there. These are the two endpoints that I'm looking for. All right, let's take a look at our next question. Question number 2. The set of ordered pairs below is a relation. Which relation has the same domain as the given relation? Well, first off, let's identify what our domain is. Our domain is our set of all possible x values, that being the first one here. So I've got 0.5, 1.5, 4.0, and 6.5. So if I were to list my domain, I would list it, and I would go from the least to greatest, so 0.5, 1.5, 4.0, and 6.5. All right, so that's what I'm looking for. I want those 4 x values found down below. Let's take a look at A. Right away, I see number 1. Well, 1 is not one of the numbers I'm looking for, so I know it's not A. In B, I see I've got 0.5. That's good. 1.5, 4.0, and 6.5. So that is our correct answer. Let's verify that the others do not work. This one has a x value of 2, and this one has an x value of -1. So right away I can see that those are not options either. That gives us B, the only one that matches in our domain. Again, domain is our x values. Let's take a look at the next question, question number 3. A teacher buys some pencils. He buys 2 pencils for each of his students. He buys 10 additional pencils. Each pencil costs 10 cents. Which equation describes the total amount of money in dollars that the teacher spends on the pencils as a function of the number of students? So we're looking for our slope-intercept form, y equals mx plus b, all right, where this is going to represent my money, all right, and this x is going to represent my students. So what I need to find out is how much are they spending per student? That's going to be my slope. So it's going to be y equals, and how much per student? Well, it's 2 pencils for each of the students, and each pencil is 10 cents. That means that he's going to be spending 2 times 10 cents, which is a total of 20 cents per student. So I'm going to give 20 cents per student, plus an initial amount. He buys 10 additional pencils. Well, 10 pencils at 10 cents a piece, if we multiply that, we find that that is 1. In other words, $1. Plus, he's going to spend $1. So that's our function that we're going to be looking for here. He's spending 20 cents per student plus $1 additionally, and that can be found here as option C. Let's take a look at question number 4. The table below represents a function of x. Which equation describes the function? Well, before I even look at those, I can find my equation all on my own without looking at the multiple choice options. That's the best way to go. And I know that my equation is going to follow my format, y equals mx plus b, where m is going to be my change in y over my change in x, and b is going to be my y-intercept. Let's start by finding my slope. My change in y, I can pick any 2 points I want. I'm going to go from 16 to 12. I'm going down 4. So my change in y is down 4 over, I must use the same 2 points going from 4 to 6. I'm going over 2. So down 4 over 2 gives me a slope of negative 2. I know now that my equation is going to begin with negative 2x. However, I don't know my y-intercept. There's a couple ways you could go about finding it. You could work backwards in the table knowing that this is 4, and you could go back by 2 to go to 2, and then go back by 2 again to go to 0. And then you could go up by 4 and up by 4. I'm, however, just going to pick one of my points and plug it in. I like to do it algebraically. I'm just going to pick my very first point where x is 4 and y is 16. Knowing that, I can plug that in, giving me 16 equals negative 2 times 4 plus an unknown value of b. And that's going to give me negative 8 plus b, and I can solve that to add 8 to both sides, and 16 plus 8 is going to give me 24 as my initial value or my y-intercept. Now that I know that, I can come back and I can rewrite my equation saying that y equals negative 2x plus 24. All right, and that's the equation that I'm going to look for down below. All right, now let me slide down and look for that. And I can see there that that is option B for me, negative 2x plus 24. Let's take a look at our next question, number 5. Barry paid a total of $62 for 3 hours of driving lessons. This included a $20 fee for the driver's manual and an hourly rate for the use of the drive the car. What is the hourly rate that Barry paid? Well, if we look at our slope-intercept form, y equals mx plus b, let's look at the values that they're giving us here. They're telling us the total was $62. That means y was 62. They're telling us it was for 3 hours. That's my x value. I don't know my slope, but I know that x was 3. And they're telling me an initial fee. All right, that was the starting point that we added 20. And if we plug each of those pieces in, we can rewrite this as 3m plus 20. And we can just solve that in order to find out what our hourly rate is. All right, so we can subtract 20 from each side, and we get 42 equals 3m. And then we can divide by 3 on each side to find that 14 is equal to m. In other words, $14 per hour is going to be the hourly rate, and that is A right here. Let's take a look at the next question. Number 6. The graph shown below represents a linear function. Well, let's see what the question is. Which equation describes the linear function? And I want you to pay particular attention to the fact that we are not looking at slope-intercept form here. Although you could take each one of these and you could distribute, and then you could subtract the 1 in this case here, you could distribute, and you could add the 1 in this case, and that would give you your slope-intercept form. But what they're actually using is point-slope form. Let's take a look at that on the formula sheet. Here's our formula sheet for the Keystone Exam, and if I go down, I can see the linear equation section is in the bottom left. And if you notice, we have something known as the point-slope formula. The point-slope formula is when you have a point and a slope. So in this case, the point is x1, y1. You pick any point that they give you. The y value goes here. The x value goes here. It's always subtraction. All right, that's going to help us eliminate some options. And then my slope is what we put right there. So let's come back now with that in mind, and let's identify which of our options would represent this function. Here, the point that they gave me is the point 3, 1. And even though you could go ahead and calculate the slope by picking 2 points, I noticed that all 4 options do not change in the slope. The slope is always 3/5, so that's not going to make the difference. What we need to do is we need to take our point 3, 1, and we need to make sure that 3 is the x value, as we can see here. It always puts the x value over with our x, so that's good. We've got 3, 3, 3, and 3. But remember what I said, the point slope formula is always y minus y1. All right, it's going to be y minus y1, and it's going to be equal to m times x minus x1. And in this case, being the point 3, 1, both x and y are positive, so we should be looking at 2 subtraction symbols, and that's what we see here in D. It's the only option that has 2 subtraction symbols. Here, this addition is wrong. Here, this addition is wrong. And here, both additions are wrong. All right, we need to make sure that we are subtracting for our point slope formula, and this is all obtained from our formula sheet. Let's take a look at the next question. Number 7. Martha earns money sewing curtains. She charges a flat fee to meet with a customer and take window measurements and an hourly rate to sew curtains. The graph below shows the relationship between the time and hours Martha works on sewing a project and the total amount in dollars she charges. What is the hourly rate that Martha charges for sewing curtains? Well, if we're looking at an hourly rate, we're really asking us to find the slope, or M, our change in y over our change in x. To find our slope, you can pick any 2 points, and I'd like you to pick points that have whole number coordinates. So here, I'm going to go with the y-intercept. That's a nice point there of 0, 20. And I'm going to pick the very next point that I notice that has whole number coordinates, here being 2, 40. To find my change in y, I start at the leftmost point, and I ask myself, am I going up or down, and how far? Well, in this case, I'm going up 20. So when I go to write the slope, I go up 20, in other words, positive 20. Then I'm going to say over, because I'm going over top of the next number, which would be our change in x, but I'm also going over from left to right on my graph. And how far am I going over? Well, I'm going over 2, because I'm going from 0 to 2. All right, so therefore I'm going up 20 over 2. And 20 over 2 can be reduced down to 10. In other words, we're dealing with the fact that she is charging $10 for her hourly rate. Let's take a look at the next question. Number 8. The scatter plot below shows the relationship between the number of video files X stored on a computer and the number of gigabytes Y of storage space available on the computer. All right, we've got our graph. And then it says, based on the scatter plot, which equation represents the line of best fit that can be used to predict the number of gigabytes of storage space available on the computer based on the number of video files that can be stored on the computer. A lot of words basically to ask you which of these 4 equations would represent the line of best fit. Now, our line of best fit, I'm going to show you something that works for me. I call this the river. However, that's not a technical term. The technical term would be the trend. But what I do is I just outline my points here above, and I outline my points below. And this is a pretty strong correlation because our points don't have much variance to them. All right, I've got a very skinny river. That's how I know my correlation here. But if I look at that trend as it continues, I can see just about where it's going to hit on my y-axis, and I can notice that's going to be somewhere around here. All right. Now notice this is 225 at that point right in the middle, so it's going to be somewhere between 225 and 250. And looking down below, I notice that the only number that exists between 225 and 250 for my y-intercept is that 227 in C. 250 would be close, but that would really be on the high end if it was up top there. 116 is definitely too low, and 189 is definitely too low. But let's just verify that our slope of -8 makes sense, because that means we're going to be going down 8 and over 1. Now, it's a little bit difficult here to go down 8 and over 1. All right, so we can change that slope. If I'm going down 8 over 1, but here I'm going by 25s, it might be easier for me to look at going down 80 and over 10. What I did was I just multiplied each of those by 10 to get an equivalent fraction. So I can pick any point like this one right here. It's about 225. And if I go down about 80, all right, if I go down about 80, that's going to be 25, 50, 75. So going down about 80 would be about right here. All right, and if I go over by 10, I'm currently at 1. I want to get over to 11. So let me just trace this over, all right, to 11 right there. And I can see that I would still be within my river doing that. So that means that this slope is a good slope. So I am much more confident in my answer that -8x plus 227 would be a good line of best fit to represent this situation. Let's take a look at number 9. A data set shows a basketball team's final scores for one season. Some of the information about the scores in the data set is listed below. The minimum value is 42, the lower quartile is 54, the median is 60, the upper quartile is 72, and the maximum is 90. Before I go any further, what they just described is what a box and whisker plot would look like. And although I'm not going to use a number line, I'm just going to mark this out and draw what my box and whisker plot might look like. All right, I've got my box and my whiskers. All right, and I see my minimum value they said was 42. My lower quartile was 54. My median was 60, and my upper quartile 72, and my maximum value was 90. And now they say of the team's final scores for the season, 75% of them are most likely to be between which between which two values? Well, each one of these sections, let me mark off what it represents. Each section here represents 25% of the data. No matter how big or small that section is, each section is always worth only 25%. That means I'm looking for the two values that they're giving me to cover 3 of these values. Let's start with the first one, between 42 and 66. Well, first off, 66 isn't even one of our markers here. It's not our minimum, not our maximum, it's not a quartile, not the median. All right, so that one's out. Let's look at the next one. 42 to 72. Well, 42 would be here, 72 would be here, and that includes 3 of our percent sections. That would be a total of 75%, so that's our answer. Let's verify that the other ones are not the answer. All right, between 60 and 72, I'll do this one in green. If I come between 60 and 72 here, we said that's only 25%, not 75%. And between 72 and 90, all right, that is also another 25% there, not 75%. So neither of those would work in this case either, leaving B as my answer, the only one that gives me a range there of 75% of the data. Let's take a look at the next question, number 10. The owner of an ice cream stand conducts a random survey of 50 people to determine which ice cream flavor customers prefer to buy. The bar graph below shows the results of the survey. We can just scroll down a little bit there. All right. The ice cream stand is expected to serve 350 customers on the first day of summer. Based on the results of the survey, which value is most likely the number of customers who will buy an ice cream flavor other than chocolate on the first day of summer? One thing that we have to recognize here is that initially this is out of 50 people, and we want to now make it a prediction based on 350 people from this result. And we want to look at a flavor other than chocolate. So instead of trying to estimate all of the other flavors, instead of trying to estimate here, 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 and here, I'm going to make my life a little bit easier, and I'm just going to estimate chocolate. Because if I know that chocolate right here, that is just past half, but not quite close enough, I'm going to say that that represents 18. If I know that 18 out of the 50 people represented chocolate, then I can just take that 50 and subtract 18 to find that everyone else would represent 32. So 32 people in this survey would choose an ice cream flavor other than chocolate. Don't jump on that yet because that's out of 50 people. So I'm going to say 32 out of 50 people chose a flavor other than chocolate. And we want to know how many people out of 350 people would choose a flavor, and therefore we can set up a proportion. If we set up that proportion and we cross multiply, we'll find that 50x is equal to 11,200, and we can divide by 50 on both sides. And when we do that, we'll find that x can give us a value that is approximately 224. Well, that's our estimate of how many people out of the 350 would choose a flavor other than chocolate. And that's our option D down here below. All right, let's take a look at our next question. Question 11. A scatter plot shows the relationship between the distance in miles from a local airport to the various cities and the time in minutes a flight between the airports takes. The equation below describes the line of best fit for the scatter plot. Based on the equation, which value is the most likely the distance in miles between two airports when a flight between the airports takes 240 minutes. Who cares about the scatter plot at this point? They're giving us the equation, and all we have to do is take what they gave us and substitute it back into the equation. Now be careful. 240 minutes, what variable is that going in for? Well, x represents miles, y represents minutes. So I need to substitute this in for y. That's going to give me an equation that is 240 equals 0.16x plus 58.62. And then from there you can simply solve, subtracting the 58.62 from each side. All right, and then I'm going to get 181.38, and then I'm going to divide by 0.16 on each side. And that gives me a value of 1,133.625. All right, and if we round that, because we're getting an estimate here, this 6 would then cause me to round that up, giving me a value of 1134, all right, as my estimate, and I can find that as option A. That's how many, that's how many miles we're going to estimate that these two airports are apart. Let's take a look at the next question. Number 12. There are 28 students whose last names begin with the letters G, H, J, or K. Information about the probability of randomly selecting one of these students is listed below. Probability of selecting a student whose last name begins with G is 1/7. The probability of selecting a student whose last names begin with G or H is 5/14. How many of these students have a last name that begins with H? All right, well, first thing that we have to understand about probability is you're always looking for how many are the number that you're looking for out of the total number of people, and you reduce that fraction. So when we look at this first one right here where it says the probability of selecting a student whose last names begin with G, and it says 1 out of 7, I have to ask myself, how many students is that out of 28? Because 28 is the total given to us. Well, if I were to multiply that by 4, I get 7 times 4 is 28, so I can multiply my top by 4 to realize that 4 students out of the total number of students must begin with the letter G. All right, now we look at the next part, and we have to understand when we see this keyword or, G or H, that tells us to take G and add it to H to get our total number of people that are G or H. So if I look at 5/14, and again I ask myself, how many out of 28 is that? Well, I see 14 times 2 is 28. So that's 10 total students, all right, that are the combination of G and H. Essentially, we're saying that 4 students with the letter G plus an unknown amount of the letter H is a total of 10 students that are G or H. And I can simply solve that by subtracting 4 from each side to find that there must be 6 students with the letter H that begins their last name. And that's how I can get this number over here, 6, which is our correct answer. So there's 6 total students out of the 28 that have a letter H that begins their last name. All right, let's take a look at the next question. Now we get to our first constructed response item here, number 13. Jerry sells a particular type of coin online. The amount he charges his customers for the coins includes shipping. Jerry uses the equation shown below to determine the total amount Y in dollars he will charge for X coins. How much does Jerry charge a customer for 10 coins? Well, they're giving us a value here. We have to always identify which variable does that value represent. And here we see that X represents the coins. So they're basically saying, find Y when X is 10. And I can simply plug that in. All right, so I'll find that Y is equal to 32.95 times 10 plus 12.95. And if you plug that into your calculator, you'll find that this gives me 329.5 plus 12.95. And then we find that the cost total charge is $342.45. And that's our value. You can take that and plug that in right here. All right, so that's our first part. Let's take a look at the second part. Explain what the number 3295 means in the context of this problem. All right, and here I'm asking you to select it from below. You might have to actually write this out in your own words if you're on the Keystone exam, but let me break down the different parts for us. Let's start off with Y. All right, I have Y right here, and if I look up above, it shows that Y is my total amount. All right, so that's the total amount that we're going to charge. I'm going to go to my next color here, and I'm actually going to go to X at this point. I'm going to do the 3295 last because that's what this question is really looking for. All right, and we see here X represents the number of coins. All right, and then we see our next part here. I'll do this in blue. 1295, this is always a one-time charge. So what is the one-time charge here? Well, here we see the amount he charges for his customers. The amount he charges his customers for the coins includes shipping. Shipping would be that one-time charge. So this is my shipping fee. All right, because it's not going to be a different amount of shipping per coin. It's just a flat rate fee for shipping in this case. So down below, I'm going to see Jerry charges an initial fee. We know that $32.95 is not the initial fee. $12.95 is the initial fee. We also know that $32.95 is not the cost to ship the coins because that's the initial fee. So I can take those both out. All right. I also notice the next one here. It says the customers ordered $32.95 coins from Jerry. No, coins is the X. All right, X is the number of coins, so I'm crossing that out in green because $32.95 is not X. It's the number in front of X. And then it says the total cost, I'm going to cross that one out. The The total cost to purchase the coins is $32.95. No, that's my y. All right, and so I color-coded those to see which each piece they were trying to trap you with. And we get to the very bottom where we see what it actually represents, and that is that $32.95 is what he sells per coin. And how do we know that? Well, this right here is my slope. The number in front of x is my slope, which is always my change in y over my change in x. Well, in this case, what does y represent? Y is my cost, all right, my total amount. What does x represent? X represents the coins. So what does $32.95 mean? That means $32.95 is the cost per coin. All right, that's what I see from my slope. It's my cost per coin, the cost per one amount of coins. You can also remember that because it's multiplied by x. So it's the units of y, my cost in this case, per, what does x represent? Or per x, so per coin. All right, so that's two ways to know what it is. Slope is always my change in y over change in x to give you that rate in units. All right, and also to know that it's always per the x value. So whatever x represents, it's always per that. So in this case, it's $32.95 per coin. In other words, our cost per coin. All right, so that's what we see down here. That's why that last one is my option. Let's take a look at the next part, part C. Zach and Dave each bought some coins from Jerry online. Dave bought 5 more coins than Zach bought. Explain why it is not necessary to know how many coins Zach bought to determine how much more Dave paid than Zach. Well, our last question asked us what this $32.95 represents, and the $32.95 represented the cost per coin. And that's why we don't need to know how many each bought. If we know he bought 5 more coins, well, that's simply $32.95 times 5. All right? That cost is going to be $164.75. All right? So it doesn't matter how many Zach bought. We know if Dave bought 5 more, he paid $164.75 more, because that's the only thing that varies based on the coins. Our initial fee, $12.95, does not vary because it's not attached to a variable. All right, so in this case here, the only thing that's going to vary is what he paid per coin. All right, and we know that was 5 more coins, and that's why I multiplied that $32.95 times 5 to get my total amount there. Again, you'd have to give a full explanation on the Keystone exam as to why it's not necessary here. I'm just asking you to prove it so that I can get you a fill-in-the-blank one there. Let's take a look at the last part to this open-ended question, D. Jerry has a sale on his website. During the sale, Carrie bought twice as many coins as Lou bought. Carrie's total cost is twice Lou's total cost. Explain how you know that Jerry charged $0 for shipping during the sale. All right, one thing that we have to recognize here is that if the number of coins was double and the cost was therefore double, this must be a proportional relationship. All right, it must be proportional. Proportional means that as our number of coins is doubled or tripled or anything like that, you can also double or triple the cost that's involved because there's no other additional fees. And that's what proportional does. Proportional is going to take our equation here and it removes that because there's 2 characteristics of a proportional relationship. One, it is linear. In other words, it grows at a constant rate. All right, the second characteristic of a proportional relationship is it goes through the origin or starts at 0, 0. All right, in other words, it could be represented by the equation y equals mx. No plus b because the b would be 0 and you're not going to add 0 into that equation. That's what makes something proportional. And therefore, you can see that whatever I'm multiplying by x, it's going to get me that y amount, just as I multiply it there. There's no additional fees, and that's where this could actually work out. Now, an explanation, I'm not going to write out a full explanation, but I'm going to show you what acceptable explanations they would accept here. So let's take a look at some of those. Here's a sample explanation that they would see. Since Carrie paid twice as much for twice as many coins, the total cost is directly proportional to the number of coins bought. This means the shipping charge must have been reduced to $0 or $0. If there was a shipping charge, Carrie's total cost would have been less than twice as much as Lou's total cost, or in another equivalent. And you could even give examples. You could show examples that do not work when you're using the $12.95 shipping, and you could show examples that do work giving a $0 shipping to kind of prove your point. So any of those would be fine. I am doing this as an open-ended because there's no other way to really assess your explanation piece of this, so I will be grading it for you. All right, but get some sort of explanation that talks about it is proportional, and that proportional requires that we have a 0 for the y-intercept, or we're adding nothing to the end of the equation. Now let's take a look at our second open-ended item here, or our second constructed response item, number 14. And records the number of different colored beads in a package in the table shown below. And will randomly select a bead from the package, and then, without replacing it, I just want to mark that because that is very important, without replacing it, randomly select a second bead. Based on the information in the table, what is the probability? And will first select a green bead and then an orange bead from the package. So I want a probability of green and orange. All right? And this demonstrates a dependent probability because the first action will change the result of the probability of the second one there. All right, so the probability of orange will depend on what happened first. In order to get probability, I have to first get the total number of beads that we're looking at. I'm just going to use some quick addition here. I'm looking at 1, 2, 3 4s. That's 12 plus 3 is going to give me a total of 15. Plus another 5 is 20, and another one is 25. So I know at that point there are 25 total, and I'm just going to mark that out. We have total is 25. So when I'm looking for the probability of green, I know that that is going to be, sorry, not 1. Probability of green is going to be 3 out of that 25. And tells me I'm going to multiply this probability with my second one. And the next one's going to be orange. Well, that's going to be 5, and you'd be tempted to put that out of 25. However, without replacing it means that I've already taken one bead out, which means now the total drops down to 24. And if I multiply these two together, you could just use your calculator to go straight out and multiply. I like to simplify as I go, knowing that 3 goes into 3 once, and 3 goes into 24 8 times. 5 goes into 5 once, and 5 goes into 25 5 times, allowing me to multiply this in my head, knowing 1 times 1 is 1 up top, 5 times 8 is 40. Giving me a probability of 1/40th. If you were to divide that to get your percent, you could see that the probability would be 0.025 as a decimal, or 2.5%. You could also say 2.5% if you were looking at the probability there. All those probabilities would be acceptable here in this case. All right, let's take a look at our next part to this problem. Part B. Anne has a jar containing 375 colored beads. The beads in the jar have the same distribution as the ones shown in the table. That means that I can take the proportions of this table here and apply it now to a jar that's 375 colored beads. Based on the information in the table, determine the number of red beads in the jar. So what I need to do at this point is I need to look at how many red are in this jar. Well, that's 4 out of what we said was a total of 25. And if I were to take that down to a decimal, that's 0.16 or 16%. And if I want to apply that now at a larger scale of 375, I can take that percentage as a decimal, 16% as a decimal is 0.16, and multiply it by the 375 beads to find that that would give me a total of 60 red beads, and I could put that in there. If you didn't want to use your percent, you could always set up a proportion. A proportion would look like this. 4 red out of 25 total is equal to how many red out of 375 total? And you could cross multiply at that point in order to figure it out. When you cross multiply, you find that you get 25x is equal to 1,500. And then you could divide by 25, and you'd get the same result either way. If we divide both sides by 25, we find that x is equal to 60. All right, either way you want to go about it is fine, but it's taking the probability of red from the current situation and now applying it at a larger scale of 375 colored beads. Let's look at our last part here. Part C. Anne has some marbles in 5 bags. Some information about the number of marbles in each of Anne's 5 bags is listed below. The fewest number of marbles in a bag is 21. The greatest number of marbles in a bag is 29. The mean or average number of marbles in the bags is 27. There are 2 modes for the number of marbles in a bag. How many marbles are in each of Anne's 5 bags? All right, so we don't need the table above that we've been using previously. This is just kind of a little bit of a challenge problem. We need to take our information and just do some guess and check to test out what we know. All right, first off, I want to start off with the first 2 pieces of information that clearly give us what's going on. We know the fewest is 21, and we know the largest is 29. We know that is true. All right, so we're going to start with 21 and 29. We know that's the max and min here. All right, and we know that since the mean of the number of marbles in the bag, I can kind of look at where the mean is now. If I were to average these 2 out, all right, my mean currently is equal to 25. That's the number that's going to be right in the middle. And if they're saying my mean is 27, that means I'm going to have, if 25 kind of splits it right in the middle, my other values, I need to have more values in the upper end to pull that average closer to 29. I need to get it up to 27. All right, and the last part says there are 2 modes for the number of marbles in the bag. That means that if there's 5 numbers total and there's 2 modes, then 2 numbers are repeated twice and the other number is just there. All right, so we're going to have 3 different numbers total is what we're looking for. Well, let's start off by pulling up the highest number I can to make this mean increase a little bit. And that means that I'm just going to take that 21 and I'm going to make a 29 and another 29. What if I had 3 there? What's my mean at this point? Well, if I calculate my mean at that point, I see that I have 26.3 repeating. Still not high enough. I cannot add another 29 because that would be 1 mode. All right? If I were to add another 29, that would give me 3 29s, and there would be no other number that would work out. All right, giving me that would be 3 29s, and I couldn't have 2 modes at that point, basically. So I need to add another number, and it cannot be 29, but it needs to be higher, all right, than 27 to pull things up above or closer to 27. So that means that I'm going to go 28, 29, 29. And again, I'm going to mark this out as my first mode. This gives me a mean, just so we're aware, of 26.75. Still not high enough. I wanted to get it to 27, so I need another number higher than 27 to pull it up to 27. And a big heads up, I know that 2 of the numbers are going to be repeated twice. If 29 is repeated twice and 28 is being used here, then maybe 28 is my second one that's going to be repeated twice. And I can go 21, 28, 28. That gives me my second mode there, and 29 and 29. Just to test that out. And at that point, I can see that my mean, if I add them all up and divide by 5 at this point, I see that my mean is indeed 27. I have 2 modes, both 28 and 29 are my modes because both are repeated twice. I have 5 total numbers with a minimum of 21, maximum of 29, and that's what my final answer is going to be. It's a little bit of guess and check here, all right, but the key is to recognize your min and max first, to recognize that 2 numbers will be repeated twice, and to recognize that since my mean was initially less than 27, I needed more numbers above 27 to pull it up. All right? Every time your mean was less than 27, you need a number above 27 to pull it up to 27. If your mean was 27, then you just want to get more 27s in there to keep it the exact same. You wouldn't want to go above and below. All right? Or you could always add numbers that are equally distant from the mean to add it to our situation that would not change the mean. That's how means work. All right? When you have more numbers above the mean, it pulls the mean up. More numbers below the mean pulls the mean down, and numbers equally distributed on either side of the mean or that are equal to the mean itself will not change that mean. All right, so that's our one here. A little bit of guess and check for you, a little bit of a challenge, and that's what's really going to test your advanced level on this exam here. All right, and that is the end of it. I hope you're doing your absolute best. Feel free to go back, look at any of these questions again, and do the practice test again and again until you can demonstrate proficiency on your own. Good luck.